Assalamualaikum warahmatullahi wabarakatuh and salam sejahtera. My name is Muhammad Akid Rasid and my number MATRIK is 01DK20F1133. For today's video, I'm going to present you guys a 1, 2, and 3 dimensional flow, which is in subject Fluid Mechanics, code DCC 30122. First, let's get to know the fluid flow. What is the fluid flow? When a fluid passes through a point or path, the various parameters associated with the flow of fluid change in different patterns. In this article, we will study the classification of different types of fluid flow according to the conditional variance of flow parameters over space and time. The two common parameters of any fluid flow are the velocity of the fluid particles and the pressure of the fluid under consideration. The flow of fluid can be divided into different patterns, which is based on the variation of flow of parameters with time and distance. Also, the advantages of characterizing the flow of fluids, as some patterns helps to analyze it under the appropriate solution paradigm. Next, we are going to let you know about the types of fluid flow. You guys can also this as the concept of fluid flow due to the presence of shear stress. There is 5 fluid flow, which is you guys can see real and ideal fluid, compressible and incompressible, uniform flow and steady flow, 1, 2, and 3 dimensional, and the last one is closed and open system. But for this presentation, I will go into explain to you guys only about 1, 2, and 3 dimensional flow. First, let's start one-dimensional flow. What is one-dimensional flow? The flow is one-dimensional if the flow parameters like velocity, pressure, depth, and so on change only in direction of flow at a given moment and not across the cross-section. The flow may be unstable. In this case, the parameter alters in the time but is still not across the cross-sections. For example, a one-dimensional flow is the flow in a pipe, which is as figures shown. Well, all flow parameters can be expressed as function of time and space coordinates only. Single space coordinate is normally a distance between measured along the center line, which is not significantly straight, in which the fluid is flowing. In fact, the fluid is never one-dimensional because the viscosity reduces the velocity to zero at the solid boundaries. However, very valuable results can often be obtained from one-dimensional analysis if the non-uniformity of the actual flow is not very great. Last one is the average values of the flow parameters on any section which is perpendicular to the flow are supposed to be used to the whole flow in the section. Two-dimensional flow. Two-dimensional flow, if it can be assumed that the flow parameters differ in this direction, in direction of flow and one direction in the right angles. In this type of flow, the streamlines are curved in lines on one plane and are same on every parallel plane. An example is flowing of a wave for which typical streamline can be seen in the figure below. All flow parameters are purposes of time and two space coordinate, which is say x and y. No variation in the z direction, and similar streamline patterns are found in all planes for the z direction in any instantaneous direction. Three-dimensional flow. In the three-dimensional flow, the hydrodynamic parameters are functions of three spaces, coordinates, and time. Therefore, the motion of a fluid element in space simultaneously has three distinct characteristics, which is translation, rate of deformation, and rotation. Before I end this video, these are the quotes you guys can use in your daily basis for your lessons as civil engineering student, which is there can be little doubt that in many ways The story of bridge building is a story of civilization. By it, we can readily measure an important part of a people's progress. By Franklin D. Roosevelt, 1931. Thank you, that's all from me.